Hi everybody! Welcome to Module 6 of Pluralsight's course on Modern Software Architecture. Dino Esposito here. Events are a concept that is empowering software beyond imagination, and even plain CRUD systems, common applications are going to be touched. As soon as simple forms of business intelligence and statistical analysis become subject of customer requests, your traditional vision of an application starts wobbling and sometimes even collapses. At a deeper and more insightful look, the real world is mostly made of events. We see events after facts, and events actually are notifications of things that just happened. In software, instead, we rarely use events in the business logic. We tend instead to build abstract models that hopefully can provide a logical path for whatever we see in the domain, and sometimes, working this way, we end up with a root object we just call God or universe. Events may bring some benefits, key benefits to software architecture. Primarily, this is because events are immutable pieces of information. And by tracking events, you never miss a thing that happens in and around the business domain. And finally, events can be replayed, and by replaying events, you can process their content and build on top of that multiple projections of the same core data. In this module, we'll start by giving an architectural perspective of events. And then we'll proceed showing what it means to have events as the primary data source of the application and what it takes to replay events and build ad hoc projections of data. Events, keep this in mind, are really mind-blowing. In Module 5, we have seen the benefits of an implementation of the command stack based on messages being exchanged between the presentation layer and the business layer via the application layer. I briefly touched on Module 5 on business events that may be optionally saved to an ad hoc store in order to log business-relevant facts that just happened. In Module 5, the focus was more on the use of messages and events to implement business workflows triggered by commands. In that context, events were just cross-handler notifications of things that just happened for handlers to possibly react. This is just the first step of a longer evolution aimed at transitioning software architects from the idea of models to persist to the idea of events to log. As I say things, this is the starting point of a change that will have a deep impact on system architecture. Now, let me tell you the story of my personal epiphany with events. You may have heard about the story of the apple that fell on the head of Sir Isaac Newton and led him to formulate the universal law of gravitation. Recently, an analogous apple fell on my head, and the message I got was that a snapshot database approach was more than okay for version 1 of an application I wrote, but with version 2, the customer just wanted more. In particular, the customer now wants the ability to know the state of the system at a given date of the past for statistical analysis and business intelligence. You may or may not be able to extract past information and past statuses of the system with canonical and common storage techniques. Events are a more powerful approach. But, and this is the remarkable thing, and the actual apple that fell on my head, events are not just for complex applications and complex scenarios, they are also for the common application. So it is not just that you don't need events to read and store. You don't need events yet. The role and the potential benefits of events in software architecture can be illustrated starting with a very common example: invoices and their sales taxes. Any invoice nearly all over the world must include some extra VAT tax, Most of the time, the VAT is fixed and can be even treated as a configuration data or hard-coded. In some cases, and in some countries, however, the VAT varies quite often, and often it is not flat, but varies per category of goods. In some way, the percentage of VAT for a given invoice must be injected in the invoice itself. But what is going to tell you the right value for a specific good? This is, or seems to be, the perfect job for a domain service, but still a domain service needs to read the details from a persistent store, and the store must be updated as a tax law change. So let's say that you have a database for this. What is the content? How would you organize tables? One way to organize the content of such a table is having one record per each category of goods with a column that indicates the current VAT. If the VAT changes, the record is updated. When an invoice is issued, however, the actual VAT value is stored, should be stored within the invoice so that the invoice can easily be reprinted and displayed correctly even if the VAT has changed meanwhile. Let's consider, however, another way to store the VAT. You have one record for each known change of VAT for any category of goods. So you keep track that VAT was X in a given time frame and Y in another time frame. In both cases, you can create invoice successfully, but in the second case, your database has a lot more information and didn't miss a single event in the domain. This extra information makes the entire system a lot more extensible. Event sourcing is a design approach based on the assumption that all changes made to the application state during the entire lifetime of the application are stored as a sequence of events. Event sourcing can be summarized by saying that we end up having serialized events as the data building blocks of the application. Serialized events are actually the data source of the application. Look, this is not how the vast majority of today's applications work. Most applications today work by storing the current state of domain entities and use that stored state as the starting point to process business transactions. If you think this is weird, have a look at the following example. Let's say you have a shopping cart. How would you model a shopping cart? Reasonably, if you're going to model it, you would probably add a list of ordered products, payment information, for example, credit card details, maybe shipping address. Easy said, easy done. The shopping cart has now been modeled, and the model is a faithful representation of the internal logic we commonly associate with a shopping cart. But here is another way to represent the same information you can expect to find around the shopping cart. Instead of storing all the pieces of information in the columns of a single record or in the properties of a single object, you can describe the state of the shopping cart through the sequence of events that brought it to contain a given list of items. So, add first item, add second item, add payment information, update the second item, for example, to change the quantity or the type of a product, maybe then remove the first item, add shipping address. All these events relate to the same shopping cart entity, but we don't save in any place the current state of the shopping, but just the steps and related data that brought it to be what it is actually under our eyes. By going through the list of events, then you can rebuild at any time the state of the shopping cart. This is actually an event-based representation of an entity. For most applications, think for example of CRUD applications, today structural and event-based representation of entities are functionally equivalent, and most applications use to store their state via snapshot. So they just store the current state and they ignore events. More in general, the picture you see now on screen is only the tip of the iceberg. There is a more general and all-encompassing way to look at storage that incorporates events, but this is just under the surface. On top of an event-based representation of data, you can still create, as a snapshot database, the current state representation that returns the last known good state of a domain entity. This is, at the end of the day, event sourcing. And, in my opinion, we are today, for the most part, just here, right on the waterline. In summary, here are a few key facts of event sourcing. First, an event is something that has happened in the past. Second, events are expression of the ubiquitous language. Events are named using past tense verbs and are not imperative. Order created, for example, is a valid event name, but not place order. If you do event sourcing, you should store events in some way. You can go with an ad hoc relational table or a NoSQL store, or even with a specific event store product. An event store of any kind is an append-only store and doesn't support deletions. Events express altogether the state of a domain entity. To get that state, you need to replay events. To get the full state, you should replay from the beginning of the application timeline. Sometimes this may require you process too much data. In this case, you can, and actually should, define snapshots along the way and replay events as the delta of the state from the last known snapshot. In the end, a snapshot is the state of the entity at a given time. An event is something happened in the past. This is a very important point about events and should be kept clearly in mind. Once stored, events are immutable. Events can be duplicated and replicated, especially for scalability reasons. Any behavior associated with a given event has been performed the moment in which the event is notified. Replaying the event, in other words, doesn't require to repeat the behavior. When using events, you don't miss a thing. You track everything that happened at the time it happened and regardless of the effects it produced. With events, any system data is saved at a lower abstraction level than today. CQRS helps making justice of too many years of DDD misconceptions. Doing DDD right takes you to not just avoiding what DDD seems to recommend, domain model, etc., for example, but to look beyond it for alternatives. And CQRS is the first pattern you find when you look over. CQRS is the dawn of a new software design world, and events are what we find when the dawn has actually turned into a full day. More than everything else, CQRS is not just for a few apps, a few types of apps either. Be honest. At some point, relational databases have become the center of the universe as far as software design is concerned. They brought up the idea of the data model and persistence of the data model. It worked, and it still works. But it's about time you reconsider this approach, because chances are that it shows incapable of letting you achieve some results, getting more and more important in the coming days. There is no automatic call to action here. It's just warm suggestions to look beyond state and look in the direction of events. Events are a revolutionary new approach to software design and architecture, except that events are not really new and not really revolutionary. Relational databases themselves don't manage current state internally, even though they expose current state outside. But internally, relational databases work looking at the actual actions that modify the initial state. Events, in the end, are not a brilliant new idea of these days. 30 years ago, old apps still used something based on the concept of events. Simply, there was no fancy name at the time for the approach they were using. Events may be the tokens stored in the application data source in nearly every business scenario. It's just that sometimes a current state classic approach is functional as well as more comfortable to implement. Events just go at the root of the problem and offer a more general storage solution for just every system. So, what should you do today? I see two options. You can insist on a system that primarily saves the current state but start tracking relevant application facts through a separate log. Second option, you store events and then replaying through the event stream, you build any relevant facts you want to present to users as data. So in other words, from events, you create a projection of data in much the same logical way you build a projection of computed database columns when you run certain SQL queries. Let's see what it means to store events. When the user adds a product to a shopping cart, you record an event. A second product, credit card information, you change the quantity of, say, the second product, you remove then the first product, you add shipping information. From these basic facts, you can easily rebuild a projection of data and represent the current state of the shopping cart or the order that you are going to submit to the backend of the system for actual processing. So in the end, it's really about two distinct but equivalent representations of the same information. To decide whether or not in your specific scenario you need events, consider what follows. The 2 points you see on screen now. Is it important to track what was added and then removed? Is it important business-wise to track when an item was removed from the cart? If you say yes, then you probably need events. Storing events in a stream works very well, I would even say naturally, with the implementation of commands. And commands submitted by the user form a natural stream of events. At the same time, queries work much better if you have structured data. So, in the end, you need both. You need commands for storing and queries, and classic current state storage for queries. This is the whole point of CQRS, command and query responsibility segregation. As an architect, you only have to decide whether you want to have a command stack based on an event stream that works in sync with, say, an order stable, or more conservatively, you want to start with order stables and then just record an event stream separately for any relevant fact. It's a sort of middle ground to proceed step by step ahead. Just a final word of wisdom. Be aware that moving from a current state solution to a full event store scenario may require significant refactoring. So it may or may not be the case to use for updates of an existing system, but when it comes to full rewrites of systems, I suggest you take events in careful account. In software, persistence is made of 4 key operations through which developers manipulate the state of the system. They are create, update, and delete to alter the state, and queries to read the state without altering. A key principle of software, and especially CQRS-inspired software, is that asking a question should not change the answer. Let's see what happens when a new relevant entity is created and must be persisted in an event-based system. There is a request coming from the presentation layer or in some other non-UI asynchronous way. The command stack processes that and appends a new record, say an order, with all the details such as products, shipping, payment, customer details, discounts, and the like. The existing data store is extended with a new item that contains all the information it needs to be immutable. If, say, VAT information is required, the current rate is better stored inside the logged information and not read dynamically from elsewhere. In this way, the stored event is really immutable and self-contained. There's also some information of other type you need to have. Each event should be identified uniquely, and in some way, you need to give each event an app-specific code to indicate whether you're adding an order or an invoice. This can be achieved in a variety of ways, by type, if you use a document store, or through one or more discriminant columns if you use a relational store. In addition, you want to have a timestamp so that it's clear when the operation took place, and any relevant ID you need to identify the entity, better, the aggregate being stored. Finally, full details of the record must be saved as well. If you're recording the creation of an order, you want to have all order details, including shipping, payment, transaction ID, confirmation ID, order ID, and so forth. If necessary, payment and shipping operations may in turn generate other events being tracked as well. And finally, when it comes to event storage, it is transparent, the technology you use, so it can be relational, document-based, graph-based, or whatever works for you. The create operation is an event-based persistence scenario that is not much different from classic persistence. You just add a record. Update instead is different, as you don't override an existing record, but just add another record that contains the delta. You need to store the same information as with create operations, including a unique event ID, timestamp, code to recognize the operations, and more. And changes applied. You also need the aggregate ID and the delta. If you only updated the quantity of a given product in a given order, in particular, you only store the new quantity and the product ID. Storage, also in this case, is transparent and can be relational, document-based, graph-based, or whatever works for you. Note that in some cases, you might want to consider also storing the full state of the entity along with the specific event information. This can be seen as a form of optimization so that you keep track of individual events but also serialize the aggregate with the most updated state in the same place to speed up first-level queries. I will have more to say about queries in a while. The delete operations are analogous to update operations. Subsequently, we can say that the deletion is logical and consists in writing that the entity with a given ID is no longer valid and should not be considered for the purposes of the business. The information in this case is just made of event ID, timestamp, code of the operation, aggregate ID. There is no strict need of having delete specific information unless, for example, the system requires a reason for the deletion. Storage is transparent and can be, also in this case, whatever works for you. Events lend themselves very well to implement the undo functionality. The simplest way to have it done is by deleting physically the last record as if it never happened. In this way, there is a contrast with the philosophy of event sourcing, where you never miss a thing and track just anything that happens. Undo can also be a logical operation, which, for example, allows to track how many times a user attempted to undo things. But personally, I wouldn't mind a physical deletion in this specific case. What's far more important, instead, is not deleting events in the middle of the stream. That would really be dangerous and lead to inconsistent data. And now we are ready to learn more about queries. The main aspect of event sourcing is the persistence of messages, which enables you to keep track of all changes in the state of the application. Recording individual events doesn't give you immediate notion, however, of the state of the various aggregates. By reading back the log of messages, you rebuild the state of the system, and at that point, you get to know the state of the system. This aspect is what is commonly called the replay of events. Replay is a two-step operation. First, you grab all events stored for a given aggregate, and second, you loop through all events in some way and extract information from events and copy that information to a fresh instance of the aggregate of choice. A key function one expects out of an event-based data store is the ability to return the full or partial stream of events. This function is necessary to rebuild the state of an aggregate out of recorded events. As you can see from the code, it's all about querying records in some way, using the aggregate ID and timestamp to order or restrict. In RavenDB, for example, getting the stream of events is as easy as in the following code. Notice that you can code the same also using a relational database. The structure of a generic event class depends on the application and may be different or in some way constrained if you are using some ad hoc tools for event sourcing. In general terms, an event class can be anything like the following code. Again, key pieces of information are event ID, something that allows to distinguish and easily query the type of the event, timestamp, aggregate ID, and of course, event-specific data. The actual rebuilding of the state consists in going through all events, grab information, and then altering the state of a fresh new instance of the aggregate of choice. What you want to do is storing in the fresh instance of the aggregate the current state it has in the system, or the state that results from the selected stream of events. The way you update the state of the aggregate depends on the actual interface exposed by the aggregate itself, whether it's a domain class or relies on domain services for manipulation. There are a few things to mention about event replay. First and foremost, replay is not about repeating commands for any generated events. Commands are potentially long-running operations with concrete effects that generate event data. Replay is just about looking into this data and perform logic to extract information from this data. Another aspect is that event replay copies the effects of occurred events and applies that to fresh instances of the aggregate. And finally, stored events may be processed in different ways in different applications. There is a great potential here. Events are data rendered at a lower abstraction level than plain state. From events, you can rebuild any projection of data you like, including the current state of aggregates, which is just one possible way of projecting data. Ad hoc projections can address other, more interesting scenarios like business intelligence, statistical analysis, what if, and why not, simulation. More specifically, let's say that you have a stream of events. You can extract a specific subset, whether by date or type or anything else. Once you've got the selected events, you can replay them and apply ad hoc calculations and business processes and extract just the custom new information you were looking for. Another great point about events and replay of events is that streams are constant data, and because of that, they can be replicated easily and effectively, for example, to enhance the scalability potential of the application. This is actually a very, very pleasant side effect of events immutability. Now, is there any performance concern with event replay? What if you get to process too many events for rebuilding the desired projection of data? Well, to cut the long story short, projecting state from logged events, yes, it might be heavy-handed and impractical with a very large number of events. And the number of logged events in any application, be aware, can only grow over time because it's an append-only store. In many cases, however, replay only involves just a handful of events, but that's not a general rule. So, what is the workaround when you get to process in replay too many events? An effective workaround consists of saving a snapshot of the aggregate state or whatever business entities you use at some recent point in time. Instead of processing the entire stream of events, you serialize the state of aggregates at a given point in time and save that as a value. Next, you keep track of the snapshot point and replay events for an aggregate from the latest snapshot to the point of interest. Here's now a concrete application of the event sourcing theory. The web application you see on screen at the moment is an MVC, ASP.NET MVC application that represents a booking system. So in particular, imagine you can book shared resources like rooms, or in a sporting club, courts for tennis, for volley, for whatever sport you like. So at the moment, the user interface of the application shows that there is the center court booked for 1 hour at 9. If we click on the View button, we see the history of the booking number 51, and we find out that the booking was made at some time 11:54 on a given day, and it was a booking made on court 1 starting at 9 by Dino, and the length of the booking is for just 1 hour. The interesting thing now is that we have a button here also to edit the booking, and if we do that, very scanty user interface allows us to change the time the booking starts, the name of the user, and even the length. Let's say that we want to prolong this particular booking for 2 hours. So we save changes, and what we have is that the user interface has correctly and reasonably modified, updated the screen to users, so that now we have that booking 51 takes 2 hours. The very interesting thing that shows the power and the potential of event sourcing is that if we now click on any of the view buttons you see here, we have a more detailed history of the booking. So we see that it was originally created at a given time to be on court 1 starting at 9, 1 hour by Dino, but it was then updated at a later time, and the only parameter that has changed was the length, which is now 2 hours. So in the end, this demo allows us and allows users to track the whole history of a given resource, in this particular case a booking, while being able to read at any time the full information. This results from the combination, from the combined effect of CQRS, so the separation of command and read stacks, with event sourcing. And in particular, if we look at the SQL Server database, we have 2 tables here. One is the classic bookings table, where we have the list of data, so that reflects the current state of entities, and we see here that the booking 51 is now 2 hours long. But also we have another table called the logged events, and here we see 2 records, one that indicates when and how the aggregate ID 51, the booking, was created, and in the cargo column you see the serialization of all the details associated with the created event. And we also find another record, always associated with the same aggregate ID, that reflects the information that was changed during an update operation. Now, let's go to Visual Studio to take a look at the steps that make this possible. So when we click on the View button, here is the code that we work with. There is an AJAX call made to an entry point behind an API controller in the MVC application, and the method we call is booking history for the specified booking ID. And here it is the code for the API controller. This is the method booking history, which takes the ID of the booking and it calls into a history method on the booking service class. Let's see what happens here. In the booking service class, we call a get history on an history service class, and the history service class belongs as a service, as a domain service to the command stack. And this is where the magic happens, because get history returns the history of the booking, of the slot that we perceive has a booking in the UI, and it receives as an input argument just the aggregate ID. The most important step that takes place here is the query of all events in store for the particular aggregate ID. And then we go through all events and we build the history, whatever that means, given the context and the expectations of the user interface. So we are essentially building a data projection here. So given the list of available information available in the form of events, we build data, in this particular case, what we call a slot history. And in particular, the slot info here contains the name of the action for the UI purposes, when it was done, the booking ID, and deserialized all the information about the particular event, whether it is created or updated. If we go back to controller, there's another step here. So once the history has been obtained, we turn that into a JavaScript slot history, and this is an extra step only done for the purpose of making the UI nicer for users. In particular, we are normalizing data for JavaScript rendering. In particular, we are working out server-side the date to avoid troubles with the JSON conversion of dates. And I'm also stuffing into the history empty fields, empty values for elements of the booking record that have not been changed with the update. So this is the trick, essentially, that makes it so easy in the Razor view to build a table like this. And if we, at this point, if we go back, it's easy because what we see here, it's easy to understand and to match this to the code, because the updated record just shows an empty string on court ID starting at and name, because these pieces of information have not been changed in the update event. And you see essentially in the history here the details of the steps that represents the history of the booking. At the same time, on another table, the regular, current, up-to-date state of the booking is available, and this is reflected in the grid here. This is the power of event sourcing. You don't miss a thing. You can definitely arrange an event sourcing solution all by yourself, but some ad hoc tools are appearing to let you deal with storage of events in a more structured way. The main benefit of using an event-aware data store is that the tool, like a database, guarantees essentially business consistency and full respect of the event sourcing approach. Let's briefly look at one of these event-based data stores, in particular Event Store you can get from geteventstore.com. Event Store works by offering an API for plain HTTP and .NET, and the API is for event streams. In the jargon of Event Store, an aggregate equates to a stream in the store. No concerns about the ability of the Event Store database to manage and store potentially millions of events grouped by aggregates. This is not a concern of yours. The tool, the framework underneath the tool, is able to work with these numbers. You can do three basic operations on an event stream in Event Store. You can write events, you can read events. In particular, you can read the last event, a specific event by ID, and also a slice of events. And you can subscribe to get updates. This is the representation of an event as it is written to the store. As you can see, the timestamp is managed internally, and you only have an event ID, an event type, data, and there's no way, that's important, to delete events arbitrarily. Another interesting feature of Event Store is subscriptions. There are three types of subscription. One is volatile, which means that a callback function is invoked every time an event is written to a given stream. You get notifications from this subscription until it is stopped. Another subscription is catch up, and it means that you'll get notifications from a given event specified by position up to the current end of the stream. So give me all events from this moment onward, and once the end of the stream has been reached, the catch-up subscription turns into a volatile, and you still keep on getting any new event being added to the stream. And finally, The persistent subscription addresses the scenario when multiple consumers are waiting for events to process. The subscription guarantees that events are delivered to customers at least once, but possibly multiple times, and if this happens, the order is unpredictable. This solution is especially designed for high scalable systems, collaborative systems, and to be effective, it requires a software design that supports the notion of idempotency. So, if multiple times an operation is performed, the effect is always the same. In particular, catch-up subscriptions are good for components called denormalizers, which play a key role in CQRS, and in the CQRS jargon, denormalizers just refer to those components that create projections of data for the query stack.